Industrial agriculture techniques have caused substantial loss throughout our history. As an example, the Irish potato famine in the 1840s killed approximately 1 million people. Farmers produced potato offspring with clippings from parent plants, so these genetically cloned potatoes were all susceptible to the same pathogens, which caused rotting and mass starvation. In the 1930s, the Dust Bowl left more than 500,000 Americans homeless. And this is because extensive plowing displaced the deep-rooted grasses that normally keep soil moisture trapped under. The exposed soil turned into dust, which caused 1 million acres of once arable land to be useless. Today, modern agriculture persists in employing these failed techniques, which includes monocultures, which are mass plantings of one type of crop, tillage systems, which degrade the soil, and synthetic chemicals. While conventional agriculture was designed to efficiently maximize yields, sustainable farms can better withstand dwindling resources to supply food for the future. My claim is that sustainable farming is the most viable form of agriculture. Sustainable farming techniques include polycultures, crop rotation, and no-tillage systems. First, sustainable farming requires less insecticide and herbicide inputs. Second, it is more water efficient. And third, they maintain soil as a permanent and useful resource. My first claim is that sustainable farming requires less insecticide and herbicide inputs. For years, farmers used chemical pesticides to rid their crops of insects and weeds. Today, resistance is growing so that weeds and insects are increasingly resistant to these types of chemicals. Dr. Wayne Buehler, director of the Southern Region Pesticide Safety Education Center in North Carolina, explained that resistance can develop when the same pesticide or similar ones are used over and over again. Essentially, this means that when a tiny proportion of the population can survive the exposure, through natural selection, they can pass on that resistant trait to their offspring, and eventually a whole population will build an immunity. Farmers applying chemicals are applying these chemicals with decreasing effect. Polyculture is a technique where different plants are grown together in one field, and crop rotations alternate single variety crops between growing seasons. These make it harder for insects to target a single plant. Robert Bafis, Agriculture and Natural Resources Program Leader for Cornell, and Marvin Pritz, Associate Professor of the Department of Fruit and Vegetable Science at Cornell University, confirm that destructive insects are often locate their food by smell. This means that plants, especially culinary herbs, produce strong scents, which may confuse insect pests looking for a host to feed on. My second claim is that sustainable farms use water efficiently. According to the USDA, modern agriculture accounts for approximately 80% of the nation's consumptive water use. Jeffrey Mitchell, cropping systems specialist in the Department of Sciences at UC Davis, conducted a study comparing no-tillage and standard tillage operations. And tillage basically removes residue off of the soil so that the soil is more exposed to the environment. The team monitored the soil surface content on the top 0 to 5 inches and found that tillage reduced the water content in the soil's top 5 inches by 7.9% in 2009 and 8.1% in 2010, while the water content in the no-tillage plots remained the same. So basically, tillage systems lost about 8% of the water put into the soil, which increases the need for farmers to use water. The residue coverage from the no-tillage system helps regulate water evaporation by shielding the soil from soil radiation or wind, and those are the two leading causes of evaporation. Finally, my third claim is that sustainable agriculture methods maintain soil as a permanent, useful resource. According to the World Wildlife Fund, half of the topsoil on the planet has been lost in the last 150 years due to industrial agriculture practices. With this, nutrients has also been lost as well. So industrial farmers get by this by using fertilizers to replenish the lost nutrients. And fertilizers consist of nitrogen, phosphorus, and potassium. Well, potassium and phosphorus cannot be synthesized, so once these natural atoms are lost, fertilizers will not be a viable option. So sustainable agriculture relies on microorganisms in the soil, and fungi form a symbiotic relationship with plant roots and provide nitrogen by nitrogen fixing. I conclude that sustainable agriculture is more reliable than modern form of agriculture because it reduces the need for chemical inputs, uses water efficiently, and maintains soil as a permanent useful resource.
All right. Well, I like the introduction that explains some of the problems that come about because of the agricultural techniques that we've used in the past. The historical ideas that there are problems because people were not using appropriate farming techniques. I like that idea. I think you identify your proposition pretty clearly. I do think you need to give us a little bit more information contrasting what the sustainable techniques are versus the industrial techniques that you seem to be criticizing. And I think we also need a little bit more information about how or how widely these things are practiced, because I don't know what percentage of agriculture is done in the sustainable method that you're talking about and what percentage is done through the industrial practices that, like I said, you seem to be criticizing. One of the arguments that probably has not been made here, and it's a reservation argument, kind of rebuttal argument that I expect the refutation speaker will be talking about, is the practicality of these sustainable techniques, whether or not they can produce at the same levels and develop supplies adequately in order to either maintain the productivity of the farm, that's what the farmers are going to be interested in, or to produce enough food for people to eat, which of course is what the rest of us are going to be worried about. And so I think you needed a little bit more data on that. I kind of understand the concepts a little bit as you're explaining them, but it's a lot to take in a short presentation. You're kind of having to do an informative speech that explains what these processes are at the same time that you're making an argumentative presentation that says that these are superior to the alternatives that we have. And sometimes it's not really not as clear as it could be. I'm still not sure what the non-tillage technique is. I mean, I assume that you're plowing under with the tillage one, and I'm going, and what do you not do? How does that work? How do you plant seeds? How do you water stuff? How do you maintain and harvest stuff without tilling the soil? That's one of those things I go, I don't know, because I don't, it wasn't clear to me in this situation. And by the way, if it's so much more effective, why is it that people are not doing it? I think there's an underlying issue here that hasn't been explained. It's either probably more time consuming, for instance, or it's more expensive to do those kinds of things, and that might be where there's a little bit more controversy. Otherwise, you're just describing something that says, look, family farming is healthier for the land than industrial farming. I'm not sure anybody would disagree too much about that. But I don't have time to go out and pick out the weeds in my front lawn every weekend. I sometimes feel I need to use a Roundup. I don't have to worry about it anymore. I'm one of those people who let their lawn die, so I don't have to think about that. I don't till the dirt out front anymore. I thought that you did an excellent job, though, citing your evidence, trying to qualify those forces. You had good diversity of information on those points. You could, like I said, on some of the points, I think a little bit more explanation would be helpful. And I thought that you had a very solid summary. And that's it. Thank you.